Good afternoon, everyone. My name is Arman Vesh, and today I will be presenting on the topic Retrieval Augmented Generation Architecture, the power of integrated AI for enterprise data. What is RAG? It combines information retrieval, text generation, then LLM generates answer using retrieved documents and user query. It also improves accuracy and relevance. Why RAG is needed? Hallucination reduction. RAG grounds responses in trusted data, minimizing hallucinations. Private data access. RAG enables LLMs to use private enterprise data and enhancing relevance. Knowledge cutoffs. RAG provides access up to date information and overcoming LLM limitations. High level RAG architecture. This is the workflow. First, query. The user asks question. User submits a question to the RAG system. Then retrieve. Retrieve relevant data. System searches and retrieves relevant documents from knowledge base. Then generates. LLM generates response. Large language model synthesizes retrieved data and generates a grounded answer. Core components of RAG: vector store, retriever, generator, which is LLM. Each component has a specific responsibility. For vector store, it stores document embeddings and enables semantic search. Common features are fast similarity search and scalable storage. Examples are Pinecone and FAISS. For retriever, it converts query into an embedding, fetches top K relevant chunks, and controls relevance and context size. Key tuning parameter is K value. For generator, it is usually an LLM. It combines user query, retrieve context. It produces a final grounded answer. The examples are OpenAI and Anthropic. Let's look at the chunking strategies. It breaks the documents into smaller parts. The common strategies are fixed chunk size. It is simple to implement but may lose context or relevance. Overlapping chunks. It preserves context by including overlapping text but increases processing time. Semantic chunking. Semantic chunking focuses on meaning to maintain relevance but is more complex to implement. The goal is to balance context plus relevance. Why chunking matters? Too large will be noisy and too small would lose the context. Good chunking improves retrieval accuracy and answer quality. The embedding models. It converts text into vectors and captures semantic meaning. Popular embedding types are sentence embeddings, domain-specific embeddings. Choice impacts retrieval quality. The practical RAG pipeline. Ingest enterprise documents. Data acquisition. Collect and load relevant documents from enterprise sources. Chunk and embed data. Data preparation. Divide documents into smaller chunks and generate vector embeddings. Store embeddings in VectorDB. Data storage. Save embeddings in a vector database for efficient retrieval. Retrieve relevant chunks and information retrieval. Query the VectorDB to find chunks most relevant to the query's user. Generate a response using LLM and response generation. Use a large language model to synthesize a coherent response from retrieved chunks. Enterprise RAG considerations. Data privacy and access control. It ensures sensitive data is protected and access is controlled. Index updates and versioning. It maintains up-to-date and version data for accurate retrieval. Latency and cost optimization. Balances performance with the budget constraints. Monitoring retrieval quality. Monitors and improves the accuracy and relevance of retrieved information. The conclusion is RAG grounds LLMs in real data. Vector store, retriever, and generator work together. Chunking and embeddings are critical and essential for enterprise grade AI systems. Thank you.